Okay, let's continue with our discussions. Last time we stopped right here, the populations and samples. What are the difference between populations and samples? A population is the set of all items or individuals of interests. Example would be all likely voters in an election. In the Philippines, I think there are approximately 70 million voters. And the population, voting population will be that, 70 million. Another would be all parts produced in a certain day. Sorry, class. This is what we discussed during the first session. Here, let's go back. A population is the set of all items or individuals of interest. Example would be all voters in an election, which in the Philippines is approximately 70 million. So that's the population, voting population in the Philippines. If our interest is the voting population of the Philippines, that's 70 million voters. Another example would be all parts produced in a certain day, like today, for say a manufacturing company that manufactures spare parts, or all sales receipts for a certain month, like November, all sales. Or you could also say all sales receipts for an entire year. So all, that's encompasses all items or individuals of interest. While a sample is a subset of the population, like 1,000 voters selected at random for interview. The SWS, the social weather stations, usually survey 1,500 voters and selected at random to make sense of who are the leading candidates. For example, who are the leading candidates in an election campaign. Last election period, say they wanted to know Pacquiao's place in the presidential candidacy, in the presidential race, or Isko Moreno, his place in the race, or BBM or Lini. They take 1,500 voters selected at random. Another would be a few parts selected for destructive testing. Destructive testing. This is, in manufacturing, this is an essential part, because parts or materials sold usually have indication of its quality. Say at what level of impact would it become damaged. Say locally our example would be say hollow block. We have several hollow block makers in Ampayon. Usually if you want to determine how strong your hollow block is, you would subject it to a drop test. That's a destructive testing technique, a drop test. Say you start with 1 meter drop, then you let it drop at 1 meter and observe what happens to the hollow block. Would it disintegrate at 1 meter drop? Maybe not, if it is strong enough. Then if it is strong, then you can say it withstand a 1 meter drop. So you try again a 2 meter drop. And if it disintegrate in after falling for 2 meters, then your hollow block is good only for a 1 meter drop. That's destructive testing class, example of destructive testing. And most parts are usually when manufactured, they are subjected to destructive testing, be it automobile parts and most other manufactured parts, they are subjected to destructive testing. Or another example would be every 100th receipt selected for audit. The auditor's job could be daunting with so many receipts as a result of so many transactions in an institutions. So they may strategize their auditing if they think they don't have that time to scrutinize every receipt there is in an institution. So they select, say, 100 receipt selected for audit. Then they examine those receipts that they gather from every 100 receipt. That is a sample, a subset of the population. To illustrate further visually, this is population versus sample. Say, in reality, we have our alphabet, A, B, C, D, up to X, Y, Z. There are, I think, 26 of them from A to Z. And then if we talk about sample, maybe if this is the population, the entire population of our alphabet, and a sample maybe just a subset of that. Maybe just this, B, C, G, I, N, O, R, U, Y. Just a part, a small part of the population. So I hope it is clear enough what is sample versus population. Then let's ask why sample? Why do sampling? Why not scrutinize everything, every individual, every item, to be sure na walay ma-miss class? It's because sampling takes less time. It is less time consuming than a census. Census means you have to scrutinize everything, leave no stone unturned. But that can be time consuming. For example, the PSA takes a census for all households of the Philippines every 5 years. And how long do you think that takes them? And how much does it cost them? It's so much. Tako kayo na og budget if you interview everyone. While sampling is less costly to administer than a census. And with the help of statistical measures, statistical processes, it is possible to obtain statistical results of a sufficiently high precision based only on samples, based only on a small subset of the population. So that's why we use samples. That's why we do sampling, because we want to save on time, we want to save on money, and we by using statistics. Now, talking further about sampling techniques, there are statistical sampling techniques. These ones at the right: simple, random, systematic, stratified, and cluster sampling. But there are also non-statistical sampling, such as judgment call, and convenience sampling. Judgment usually refers to expert opinions, those who do that particular activity daily. We consider them as experts of their fields. And there's also convenience, meaning what is available at the moment, or what is financially or time-wise convenient. But these are not really statistically, or they are not usually regarded as very scientific. However, non-statistical sampling is still being used for a reason. We have here our business application with Wagner Orchards or farm. Kung diri pa na sa ato siguro, we call it a farm. Wagner Orchards owns and operates a large fruit orchard and fruit picking plant in Washington State. This is in America. During harvest time in the cherry orchard, the cherry farm, daghan siguro sila klase nga fruits. Daghan siguro na po sila grapes, oranges. This one is cherry orchard. Pickers load 20-pound lugs with containers. Lugs means containers with cherries. 20 pounds, something like 8 kilos, because a 1 kilo is 2.2 pounds, which are then transported to the packing plant. At the packing plant, cherries are graded and boxed for shipping nationally and internationally. Because of the volume or large volume of cherries involved, it is impossible to assign a quality grade to each individual cherry. Instead, as each log moves up the conveyor, they are mechanized there, into the packing plant. A quality manager selects a small sample of cherries. Nag-sample gyapon si quality manager. Small sample of cherries from the log. Grades these individual cherries as to size, color, and so forth. And then, si quality manager assigns an overall quality grade to the entire log from which the sample was selected. Again, because of the large volume of cherries, the quality manager at the orchard uses a non-statistical sampling method called convenience sampling. Sayon. In doing so, the quality manager is willing to assume that cherry quality, that is the size, the color, and other features of the cherry, is evenly spread throughout the container. And if not, then the quality manager would be in trouble. That is, the cherries near the top of each log, he assumes that they are the same quality as cherries located anywhere else in the container. So he's assuming, and that's actually a risk for him, because that's what is convenient for them. In the US, it is expensive to hire labor. So if the quality manager has to unload each container, each slug, just so he could sample from different parts of the container, that is not very practical on their side, because that would cost them a lot. Maybe that may cost more than the cherries itself. So for convenience, we take convenience sampling, of course, with its corresponding risk. That's still non-statistical sampling is still being used in business. Now let's talk more about statistical sampling. This is the part of sampling that we are more interested in. Here, the items of the sample are chosen based on known or calculable probabilities. And probability samples or probability sampling, there are 4 different kinds of sampling: simple random sampling, stratified sampling, systematic sampling, and cluster sampling. In simple random sampling, every individual or item from the population has an equal chance of being selected. It's done like a lottery, parang sa loto. It's not based on relationships, not based on biases, but numbers are selected by chance. So selection may be with replacement or without replacement. Samples can be obtained from a table of random numbers or computer random number generators. Katong table of random numbers, I saw this before. Before there were many computers around. Researchers used to carry this table, and it's actually a matrix, a table, a matrix, where you have numbers on one side, the the x-axis and the y-axis, and then you find your number somewhere the axis would intersect. But now, those tables are more or less computerized. In most programming languages, I believe you are familiar with C programming language. There is the function called random, and it returns a random number. Those numbers are not based on popularity or based on relationships, whom you know. It's by chance. It's by chance purely. A business random sampling application, business application for random sampling. This is about Cable One. Cable One, it's a company. A salesperson at Cable One wishes to estimate the percentage of people in a local subdivision who have satellite television service, such as DirecTV. I believe here we have Sky TV or Sky Network, and Signal. The result would indicate the extent to which the satellite industry has made inroads into Cable One's market, or nakasulod sa teritoryo sa Cable One. The population of interest consists of all families living in the subdivision. For this example, we simplify the situation by saying that there are only 5 families in the subdivision, para sa yung sabton. And these are James, Sanchez, Loy, White, and Fitzpatrick. We will let capital N represent the population size and small letter n the sample size. From the 5 families, or capital N equals 5, we select 3, a small n, that's for the sample. There are 10 possible samples of size 10 that could be selected. 10 possible combinations. These are the 10 possible combinations of size 3, sample size 3 out of 5 families. So one of these can be randomly selected, one of these combinations. Now, the stratified samples, stratified sampling. Here in stratified sampling, the entire population is divided into subgroups called strata. That's actually where the term stratified samples or stratified sampling comes from, strata. Subdivided into subgroups according to some common characteristic. The researcher would have to determine what this characteristic is, or maybe characteristics. Then perform random sampling to each subgroup. then samples taken then are combined into one. Here, for example, if this is the entire population points of interest, it is divided into 4 strata. Why 4? The researcher would have to determine based on experience. Why 4? It's hers or her decision. And for each subgroup or strata, select a number of sample from each strata. Here, we select 3 from each strata. Why 3? Again, it's up to the researcher to determine why 3 from each strata. Maybe he or she wants 12 out of entire population. So because he decided to have 4 subgroups, then 12 divided by 4 is 3. So he selected or she selected 3 from each subgroup. This number is actually, it depends on the researcher. It's for the researcher to determine. And then you group those samples taken from the subgroups. Kini siya kana gibutang diha, or actually I think diha, kana silang tulo gibutang diha, kana silang tulo gibutang diri, kana silang tulo gibutang diri. Okay? Stratified sampling. Actually, stratified sampling is still uses the basic sampling technique, which is simple random sampling. Is applied. The first sampling technique is still involved in stratified, applied to each subgroup. Now here is an application for business application for stratified random sampling. The Federal Reserve Bank, this is the central bank in the USA. Sometimes the sample size required to obtain a needed level of information from a simple random sampling may be greater than our budget permits. So, at other times, it may take more time to collect than is available. So, time is a constraint. Stratified random sampling is an alternative method that has the potential to provide the desired information with a smaller sample size. The following example illustrates how stratified sampling is performed. Each year, the Federal Reserve Board, that is the group of people, or shall we say a committee that runs the Federal Reserve Bank, asks its staff to estimate the total cash holdings of U.S. financial institutions as of July 1. So they want to estimate pila gyud ang amount, ang kwarta sa tanang financial institutions sa US. And why July 1? Because July 1 is the first day of the financial year. I don't know why, but July 1 is the new year for financiers. And their year end is June 30. Unlike our calendar year, we say that New Year starts with January 1 and our year end is December 31, right? But in financial world, the New Year starts in July 1. So the staff must base the estimate on a sample. Note that not all financial institutions like banks, credit unions, and the like are the same size. A majority are small, some are medium-sized, and only a few are large. However, the few large institutions have a substantial percentage of the total cash on hand. To make sure that a simple random sample includes an appropriate number of small, medium, and large institutions, the sample size might have to be quite large. As an alternative to the simple random sample, the Federal Reserve staff could divide the institutions into three groups called strata: one for small, one for medium, and one for large. Staff members could then select a simple random sample of institutions from each stratum or subgroup and estimate the total cash on hand for all institutions from this combined sample. Figure 1.10 shows the stratified random sampling concept. Note that the combined sample size n sub 1 plus n sub 2 plus n sub 3 is the sum of the simple random samples taken from each stratum. Here's figure 1.10, stratified sampling example. The whole population is composed of all the cash holdings of all financial institutions in the U.S. Their worth, how much they are worth in dollars. So because there are so many of them and they don't have enough time, they stratified the population. They classified them into large, medium, and small. Then they select sample for large, sample for medium, and for small, and calculate the total amount from there. Now, let's talk about systematic samples. Systematic sampling is actually similar to some extent with stratified sampling technique. The researcher would need to decide on sample size, and for that sample size, you divide the frame of n, or this is the population, into groups of k. So we have this mathematical expression: k is equals the population divided by the sample size. Then randomly select one individual from the first group. So you might want to throw a dice to start with, and then once you have that, select every key. This one is the key, whatever the number, this number is. In this case, if n is 64 and the sample size is 8, then 64 divided by 8 would be 8. So if, say, if you throw a dice for real random technique, wala gyud pabor-pabor unsang number for the first group, then you can determine the next sample. by using the kth individual thereafter. You notice is you still divide the number, the population, but the main difference with the what's the other one, stratified sampling, is that in systematic sampling, the interval between the samples are consistent or even. Unlike the other one, unlike the this one, if you notice, the sample within the subgroup are not uniform. The interval is not consistent. What is consistent is there are 3 from each subgroup, but as to which in the subgroup, where in the subgroup is not uniform, and there's no pattern. Here there is a pattern. Okay, that's the main difference between stratified sampling and systematic sampling. Business application for systematic random sampling. From the National Association of Accountants. A few years ago, the National Association of Accountants, I think we have a local counterpart for this, Association of Accountants in the Philippines, JPEA, I think JPEA, Junior Association of Accountants in the Philippines, something, considered establishing a code of ethics to determine the opinion of its 20,000 members. 20,000 members, this is the population that the researchers are interested in. The questionnaire was sent to a sample of 500 members. So 500 members divided by 20,000, that's, I think, something like 2%, 2.5%. Although simple random sampling could have been used, an alternative method called systematic random sampling was chosen. The association's systematic random sampling plan called for it to send the questionnaire to every 40th member, because they divide, this is big N, this is small n, and this is K. Okay, every 40th from the list of members. The list was in alphabetical order. It could have begun by using Excel or Minitab. Minitab is also a spreadsheet like Excel, to generate a single random number in the range 1 to 40. Suppose this value was 25, the 25th person in the alphabetic list would be selected. After that, every 40th member would be selected until there was 500 members as sample. Systematic sampling is frequently used in business applications. Use it as an alternative to simple random sampling only when you can assume the population is randomly ordered with respect to the measurement being addressed in the survey. In this case, the measurement being addressed is people's views or people's opinions on ethics are likely unrelated to the spelling of their last name. So what it is saying here is that just because you have the same family name doesn't mean that you have the same opinion on ethics. That is, unless if you live in a patriarchal or maybe dictatorial society where the patriarch of the family would either kill or kick out those who differ from his opinion. So there are communities like that, where as a family you stand or you fall, but maybe not in our place, maybe not. So this is what they assume, that the spelling of their family name has nothing to do with the opinion of people, their views on ethics, because they were interested in ethics. Now let's go to cluster sampling. Here, the population is divided into several clusters, each representative of the population. Then a simple random sample of clusters is selected. So, preso gyapon, you use random generator here. The first technique, simple random sample, you use with cluster sample. But what's the difference class between a cluster and a subgroup that is used in stratified, both in stratified and systematic sampling? Here in clusters, it is actually, a cluster is actually still a subgroup, but a cluster has to be taken as all or nothing. When after using a simple random technique, when a cluster is selected, you take the entire cluster or entire subgroup and you interview all of them, not choose from the members of the cluster. You get the idea? Here it's all or nothing. It's the entire cluster. A cluster is all or nothing. Unlike in strata, where you can still select within the strata, the stratum. Then we have here another business application, this one for cluster sampling. The marketing firm plans to interview a season ticket holders just prior to home games during the current season. Well, I can't think much of a local version for this. In America and many other Western countries, they are so fond of watching games, and a season might take 2 weeks, 3 weeks, maybe 4 weeks, and people would buy ticket to watch in person, and the marketing firm wants to interview ticket holders. Now, one sampling technique is to select a simple random sample of size n, which n is to be determined by the researcher, from the population of all season ticket holders. You probably know the number of tickets sold from the sponsor of the games. Unfortunately, this technique would likely require that interviewers, the enumerators, the ones in charge to get the data, go to each section in the stadium. And class a stadium is a giant gymnasium. If you could say that we have a giant gymnasium, then this giant gymnasium is a dwarf compared to a stadium. The stadium can contain maybe 50,000, 70,000 people at one time, at the same time. So this would prove this a large area. This would prove to be an expensive and time-consuming process. A systematic or stratified sampling procedure also would probably require visiting each section in the stadium, which is may not be very easy to do during a game. The geographical spread of those being interviewed in this case causes problems. So a sample technique that overcomes the geographical spread problem is cluster sampling. The stadium sections would be the clusters. So they could divide the stadium into different clusters. And ideally, the clusters would each have the same characteristics as the population as a whole. So once the stadium is divided into a cluster, it depends on the one who designed the research, how many clusters a stadium he would or she would decide. Then they still need the simple random sampling technique to select which cluster to interview. And then this is partly convenience, really, because it is inconvenient to be going back and forth in a large area. This is indoor area with thousands of people inside. So clustering or cluster sampling is the way to go. Now, key definitions here that we have talked about. A population is the entire collection, we know this already, of things under consideration. Here's another concept here. A parameter is a summary measure computed to describe a characteristic of the population, whereas a sample is a portion of the population or a subset of the population selected for analysis. And under the sample, a statistic is a summary measure computed to describe a characteristic of the sample. Perhaps you get a little bit confused. To visually illustrate, they should help a bit. And this is for inferential statistics, actually. Making statements about a population by examining sample results. Say this is our population. Kining circle or circle ba ni oblong na blue. And then inside this is our sample. This is our sample size. Maybe by the look of it, maybe it's a cluster. No, it's one part of all the sample are taken from one part of the population. Maybe it's a cluster. We have sample statistics. Sample statistics describes the sample, and we infer, of course, subjecting it to statistical analysis, and then we draw conclusion and statement about the parameters. It's like, say, for example, we say if the population, we talk about all Americans, and we see a few Americans, and we say Americans mga dagko, mga tag-as. That's our perception, our inference, as our statement about Americans, because we saw a few sample of Americans who are mostly tall and big. Although in reality, there are also Americans nga gagmay o mugbo. So that's some example of making statements about a population by examining. That's not very scientific, but that's example that I can think of. Remember the inferential statistics we talked about earlier, drawing conclusions and or making decisions concerning a population based on sample results, and how they are used to estimate and to test hypotheses. There's an example here. Say we want to estimate the population mean weight, average weight, using the sample mean weight. Meaning we want to estimate unsa ang pilay timbang sa average nga, say average nga Filipino. Unsay timbang sa average nga Filipino using a sample. We take, say we have a sample of maybe 1,500 individuals. We weigh them and we take the mean, the average of their weight, and then we say that mao ni ang average weight of a Filipino. Then you can use sample evidence to test the claim that, for example, the population mean weight is 120 pounds, or this is something like 54 kilograms. Would that be true, or would that be false, or shall we accept, or shall we reject this claim based on a sample? Okay, data types. Here, finally, the book got it correct, qualitative and quantitative. There are basically two types of data. Although in C programming language, is the concept of data types is a bit different. We say integer is a data type, float is a data type, a char or a series of char or string is a data type, or any other user-defined compound data types. Say when we define a structure in the C language. But here there is the qualitative or categorical data type, and here there is also the quantitative or numerical data type. Example of qualitative are marital status. Usually marital status is single, married, divorced, separated, widow, widower. That is a marital status. Also political party. In the Philippines, we have what? Unitim, liberal. I lose track of our political parties in the Philippines, but in other countries there are only two, basically the liberal and the democratic, or the Democrats and the liberals, and sometimes there would be independent parties. Eye color also, eye color. This could be brown, black, blue, green, or gray, something like that, or maybe red. They are defined categories. That's why they're called categorical data type, defined category. Whereas in quantitative data type, these are numerical. And again, these are the kind of data types that we are interested in, because these are the data that easily computes. Although there are ways also that this categorical data can be somehow translated into numbers. But for now, we are more interested in numerical data or quantitative data. Under this are discrete and continuous data types. Example for discrete are number of children, labok anak, or defects per hour in the case of, say, a parts manufacturing company. These are counted items that you can count as a whole, 1, 2, 3, or discrete or integer. Whereas continuous data, example would be weight, voltage. These are measured characteristics. Also, time series data. Time series data and cross-section data. Time series data are ordered data values observed over time. Over time, there's always time involved. Time could be year, month, day, hour, minutes or seconds or microseconds, milliseconds. That is our measurement of time, or maybe decades or centuries or millennia. And those are time. A series of data based on time is a time series data. Whereas a cross-section data are data values observed at a fixed point in time. Fixed point in time, or something like a snapshot of data in a particular time. Isa lang siya ka-time period, not a series of time. And you can see the details of the cross-section data. To illustrate here between the time series data and cross-section data. Time series here, this is sales in $1,000. The time here is year 2003, 2004, 5, 2006. That's the time series. And for Atlanta, a particular row in this matrix, for Atlanta, the time series data for 2003, this one 435, for 2004 460, for 2005 475, and for 2006 490. This is an example of a time series data. And for Boston, this would be its time series data also. For Cleveland, in other words, class, a time series data is a data across different periods, or if it is year, across different year, if it is month, across a series of months, if it is hours, across a series of hours. While a cross-section data here, the red oblong, is a snapshot of all the data for all, can we say, maybe there's a label here that's not there, maybe a province or a state. For 2003, the data for all the states, for a particular time. That's a cross-section data. Whereas a time series data, it goes, the data follows a series of time. In this example, the time is year, a series from 2003 to 2006. So I hope it is clear, class, what is a time series data and a cross-section data from this illustration. Now, data measurement levels. What is this? Measurements, rankings, or ordered categories, categorical codes like ID numbers, category and names. They say that the nominal data is the lowest, or the basic, lowest level, and provides the basic analysis. Nominal data. These are examples, ID numbers, category names. While ordinal data, or rankings, or ordered categories, provide higher level or mid-level analysis, while ratio and interval data or measurements provide the highest level or complete analysis as far as data measurement levels is concerned. Now, what is nominal data? Nominal data are, well, the lowest form of data, yet you will encounter this type of data many times. Assigning codes to categories generates nominal data. For example, a survey question that asks for marital status provides the following responses: 1. Married, 2. Single, 3. Divorced, 4. Others. Of course, this is subjective class because it depends on how you ordered this. The designer of a questionnaire could put single as number 1. It doesn't matter as long as you are consistent. When you refer to 1, you mean married, and when you refer to 2, you mean single. As long as you are consistent throughout your discussion, you should be fine. Now, what are ordinal or ranked data? This is one notch above higher nominal data on the measurement hierarchy. At this level, the data elements can be ranked, ordered, on the basis of some relationship among them, with the assigned values indicating this order. For example, a typical market research technique is to offer potential customers the chance to use 2 unidentified brands of a product. The customers are then asked to indicate which brand they prefer. The brand eventually offered to the general public depends on how often it was the preferred test brand. The fact that an ordering of items took place makes this an ordinal measure. Bank loan applicants are asked to indicate the category corresponding to their household incomes, such as under 20,000 assigned number 1, 20,000 to 40,000 assigned number 2, and over 40,000 assigned number 3. We are almost done for the chapter. This is now the chapter summary. Class, we have reviewed key data collection methods, and we have discussed key definitions. What are population versus sample, and what is qualitative? Again, the same mistake as in the beginning, copy paste. Should be quantitative versus qualitative data. What is primary versus secondary data types, and what is time series versus cross-sectional data. We have also examined descriptive versus inferential statistics, and we have described different sampling techniques: random, a simple random sampling, stratified sampling, systematic sampling, and cluster sampling. The last 3 uses the first one, the simple random sampling. Then we have reviewed data types and levels of measurement. Okay, and unfortunately for this recorded video, you cannot ask question here. You just ask question when we meet face to face. And that's all for now.